Well, a warm welcome to this talk. It's the second part, really. It's still Saturday, the 17th of December now. We've been looking at this paper briefly in a short video that we've just looked at. This paper that's purporting to show that there's a correlation, and it's suggested that it's causal, sort of suggested that it's causal, between not having COVID vaccination and increased risk of road traffic accidents. Now, initially I had thought this was a joke, but it is put forward as a serious paper. Now, there's two ways you can kind of look at this, really. The first is, well, this is so obviously absurd, as it is. It's obviously absurd. But then when you actually look at it, and they do some pretty good statistics in the paper, it's actually quite hard to say why it's absurd scientifically, and that's what I'm going to try and do. Now, I read it and was actually struggling with this, so I've turned to the greats like Professor Norman Fenton and Dr Claire Craig, whose information I'm going to be using, who are much better at analysing these things than I am. And it's really quite a clever piece of work, this is. And will more come out about it? For example, will we get more information about the financing? Is this a deliberate attempt to deceive? Quite what is it? Because it really is quite a strange phenomena. But anyway, let's unpick it and say what it's saying and why I believe it's inaccurate, while kind of leaving those questions hanging. Do check out the comments on the short version of this video just before, because there's some really quite insightful ideas that people, especially in Canada, obviously, have about this work based in the Toronto area. Let's hope there's an investigative journalist left in Canada who can maybe get to the bottom of this. Now, I'm going to go into a bit of detail now. COVID vaccine hesitancy and risk of a traffic crash. So that is the direct title of the video there, as we see. Now, we'll see later on that this is a bit disingenuous, because it's looking at people that had accidents who were drivers, people who were passengers, and people who were actually involved as pedestrians in road traffic accidents. So really, it's a bit of a non-valid title, but let's leave the critique till later. Now, background, coronavirus disease, COVID vaccine hesitancy. They're postulating as a reflection of psychology that might also contribute to traffic safety. So they're saying, is there a common underlying cause between these two? If you're a particular type of person, does it mean to say you're less likely to be vaccinated? And does it mean that same type of person is more likely to be involved in an accident? Seems to be what they're saying. Although they do put other bits in that we looked at in the previous video that do hint that they are suggesting that it's causal, although in words they claim that, of course, it is a correlation. So there's a kind of an ambiguity that's left hanging there in this article. Now, this is me here. I think what this means, so people that take COVID vaccines are the sort of people who have less traffic accidents. People who do not take COVID vaccines are the sort of people who have more traffic accidents. That seems to be what they're saying, and the obvious answer, the obvious response to that is to say, well, this is ludicrous, which it is. But as we'll see, they do give quite a lot of evidence that needs to be unpicked in a more systematic way, really. It's a population-based longitudinal cohort analysis of adults. So this is who they're looking at, and it's in this Toronto area primarily, conducted over 1 month, or following people up for 1 month in 2021. So they determined COVID vaccination status from electronic medical records. Now, they did claim that this was anonymised, but of course, these aren't public records. So one question for the investigative journalist that we're hoping is going to take this up in Canada is how the heck did they get access to all these records? Because there's a complicated paragraph in the paper itself. Read it, it's all there, the PDFs for free public download, that says they got the data. Not quite clear how they got the data. They analysed the data. They vouch for the validity of the data, and we can take them at their word for that, I think. I think that data probably is there. But of course, you can't see it. Now, it does say that if you contact them, they will tell you how they went about getting the data, but of course they don't actually have the data to give you. So again, we're in this situation where we're expected to take people's word for it. And it's not so much that I'm reluctant to take people's word for it, although I'm certainly less keen to take people's word for it than I was 3 years ago. But the point is, it means that Professor Fenton can't analyse it independently. It means that Dr Claire Craig can't analyse it independently, and all the other brilliant people we have around the world who could analyse this independently. Tough, you can't. You've just got to take the great word that's handed down from the authors. Subsequently identified from all accidents from 178 hospitals. So they had the vaccine data, they had the hospital data from accidents, traffic accidents, from 178 hospitals for 1 month follow-up. And as I understand this, it's different months for different people. They just follow them up for 1 month. Now, the results. Over 11 million, 11.2 million people. Impressive. This is an impressive number of people. They got to this data. You can't get to it, but they got to it. And it's a large number of people that they're able to get this data on. Did they need some special... I don't know, how did they get this data? Because you can't. It's virtually going to be pretty hard for you to get. Now, of those 11 million people, in the 1 month follow-up for those 11.2 million people, 6,682 accidents. And of those, 16% were unvaccinated, 84% were vaccinated. So we see a relatively small amount of people were unvaccinated. Now, the amount of unvaccinated is probably higher than this. It's probably 18, 20, 22, 24%, but that's the figure that they're giving. And the vaccinated proportion is probably lower than that, because these are always based on sets of data, particular sets of data. Professor Fenton's pointed this out numerous times in the UK, that the number of unvaccinated is actually a higher percentage than the official government statistics typically indicate. But it's still certainly true that there's way more people vaccinated than unvaccinated. I'm not criticising that. Unvaccinated individuals, 1,682 crashes or accidents. That's 25%. 25%. Now, so in other words, unvaccinated individuals accounted for 25% of the 1,682 accidents. That's equal to a 72% increase in relative risk. So people that are unvaccinated were 72% more likely to have an accident than people that were vaccinated. Confidence intervals, 95% confidence intervals. They're 95% sure this was between 63% and 82%. Again, using standard statistical techniques, this is normal that this is done like this in scientific papers. And that gives a p-value of p equals 0.001. That's the probability that the result arose by chance. So there's 1 in 1,000 chance that the result arose by chance. In other words, 999 out of 1,000 probability that this is a genuine result. And given the statistics that they have used, given the numbers that they use, this does appear to be an accurate analysis of the data that they have used. This is why it gets quite complicated, really, because a lot of things seem to be right. Now, what about socioeconomic status? Now, to be fair, the authors do talk about this. Socioeconomic status can influence the likelihood of having accidents. How much alcohol is used, clearly. Sleep apnea. So typically people of lower social economic status have more accidents. People that drink more have more accidents, of course. Sleep apnea, these people have more accidents. So sleep apnea is usually caused by adiposity in the upper airway. And typically, not always, but usually. And what happens is that the airway closes overnight, and that wakes the person up. Because what can often happen in these people is they get woken up 10, 20, 30, 40, 50 times a night because they have difficulty with the breathing. And of course, this means they're chronically sleep deprived. So they're very tired. Therefore, they're more likely to have accidents. So that's a possible thing to take into account. Diabetics. Again, diabetes, they can go what you call hypoglycemic, and that can cause cognitive problems that they can't really think straight about things and can actually go into a hypoglycemic, reduced state of consciousness. psychological depression, dementia for obvious reasons, people with high blood pressure. Think about people with high blood pressure as they often take tablets to bring the blood pressure down, and they can become actually hypotensive, and that can make them go dizzy, and that can cause an accident. So they're actually probably a side effect of medication there, but it's a genuine phenomena. People with cancer, of course, are iller. People with COVID infection are sick. And what they did was, and again, this is quite clever stats, they took all these into account. So these are known factors that they took into account. And they statistically, very cleverly statistically accounted for all of these. And they ended up with not a 72% increase, but a 48% increase after adjustment. So they're still saying that people that are unvaccinated are 48% more likely, even when you account for all of these things, to have an accident. Now, that's quite a clever statistical analysis they've done there to come up with this 48% remaining figure. So people that are unvaccinated, 48% more likely to have accidents than people that are vaccinated. And again, they give figures here, 95% confident that it's between 40 to 57%. So again, quite clever statistical techniques, and making it really quite hard to argue against, although we will, from help from other very clever people. Again, very significant result. The increased risk extends across the spectrum of crash severity, they are saying, but actually we'll contradict this in a minute, so I'm going to put a question mark on that, because that's what they say, but it's not quite what they do. And the results are similar for different vaccines. Their conclusions. These data suggest that COVID vaccine hesitancy is associated with significant increased risk of a traffic crash. So the more vaccine hesitant are more likely, this is a direct quote from the paper, more likely to have a traffic crash, is what they are saying. And they're saying it with a straight face as well. I mean, this really is quite incredible that they've tried to wrap this up in a nice looking scientific wrapping. Anyway, let's carry on. An awareness of these risks might help to encourage more COVID vaccination. So have a COVID vaccine and you're less likely to have a road traffic accident. Appears to be what they're saying. Can they really be saying that? It does appear, that's my reading of the paper. They actually appear to be saying that get a COVID vaccine and you're less likely to have a road traffic accident. That really appears to be what they're saying. Read it for yourself. It's all there. I misunderstand things sometimes, but it's all there. Read it for yourself. But as I say, this is not just me. This is I've got in some external expertise to help me with this, because it is complicated. Right, let's carry on with this. Unvaccinated in Canada couldn't use planes, trains and buses for quite large parts of 2021. So if they weren't allowed to use, if people were unvaccinated and weren't allowed to use public transport, then clearly they would have to drive more, therefore they're driving more miles. So what would have been more accurate if this study had attempted to work out how many miles were driven by vaccinated and unvaccinated, and include not just things like diabetes, sleep apnea, alcohol, dementia, depression, but actually compare mile for mile, would have been much fairer, because people that drive more, of course, are more likely to have accidents, especially in a Canadian winter where there's a lot of adverse conditions around. The Canadian winter is much more severe than ours, and ours is bad enough, as you see from my current attire. So that was one point. Also, this data, this site's here. That one's from Forbes. That one's from can't remember. Click on it, but it's from a proper news outlet. It says vaccinated more likely to work remotely in Ontario. So if the vaccinated are more likely to work remotely, that means they don't need to commute to work. Therefore, they're not getting out as much. Therefore, there's a less chance of having accidents. And also, people that are classified as essential workers who had to go out to work, who don't have the luxury of sitting at home with a nice cup of tea in front of a computer screen, these essential workers had a lower vaccination rate. And it's these essential workers that needed to drive to work. And as well as that, there were several pile-ups in ice and bad weather that could have really caused a lot of injuries all at the same time and can further skew the data. Now, another thing is what we have, we'll look at this forest plot in a minute, this plot here, but this is the line here for the risk of no increased risk or decreased risk. And we see that the under 65s, that their data point is just here. So the under 65s were less likely to have accidents if they were unvaccinated. They're slightly less likely to have accidents. And this is consistent with this idea that they're not getting out. So, yeah, of course, some people over the age of 65 still commute to work every day, but most don't. Most don't. So this idea that people that are doing more miles are more likely to have accidents, and they just didn't seem to account for this. Because the over 65s, less miles, driving in bad conditions less. Not surprisingly, their risk of being involved in this type of accident is greater. They've got more risk of falling downstairs than other accidents, but this particular type of accident is reduced, and they didn't seem to pick up on that. So I think from this we conclude that staying at home reduces the chances of being in an accident. So let me give you some advice. If you don't want an accident outside, stay in. It's just, is that really what this amounts to? So, if you sit at home eating hamburgers and eating chips and drinking beer and, generally slobbing around, you're not going to get jogging injuries, are you? Because you're not out jogging, you're in the house. I mean, this is really pretty obvious, really, when you think about it. But when you read the paper, it's not obvious. I got these ideas by looking at these other great analysts, rather than thinking about it, because the paper itself does appear, because it's written in the language of analytical science, it does appear to be quite convincing. In fact, it is quite convincing if you just read it through. You've really got to get sort of down into it to realise why that your initial impression that it's ludicrous does actually appear to be substantiated by more in-depth analysis. Now, the title here about traffic crashes, I would say that's actually invalid, because what they actually found, patients in emergency departments as drivers, passengers or pedestrians are all classified by this same classification. So this is the way that they're classified according to their data. This particular classification, V00, V69 classification. So there were 6,682 of those. 2,856 were drivers, fair enough. But pedestrians were nearly as many, 2,637. So are they really saying that pedestrians are less likely to have an accident if they're vaccinated? Are they really saying that pedestrians are more likely to have an accident if they're not vaccinated? Yeah, that does seem to be what they're saying. And of course, a lot of passengers are involved as well. So it's not just drivers. And that's in table 3 of the study. So this is actually from the study, which was honestly reported as far as that data is concerned. Therefore, unvaccinated pedestrians are more likely to be in an accident than vaccinated pedestrians. I mean, this just, the idea that there would be any... first of all, I'm not sure the correlation exists. We haven't finished looking at the reasons yet, but if it did, it really is bizarre that this will get into the scientific literature, in my view. People were considered unvaccinated for the first 14 days after vaccination. Now, this has kind of been standard all the way through. It's the same in the UK, that people that are unvaccinated for the first week or 2 weeks aren't going to have an antibody response. So typically they're classified as being unvaccinated, despite the fact that they are vaccinated. So you're going to have some people that are vaccinated classified as being unvaccinated. And given that this study only lasted for a month, and that people that were been vaccinated for 14 days, for 2 weeks, were classified as being unvaccinated, then clearly that's going to mean that there's, for half of the time, these people were in the wrong classification. This is quite incredible, that they would not really take full account of this. So this is half the time. So how many casualties were misclassified? It turns out if 602 of the 6,682 were misclassified, any difference between the two groups would vanish completely. And that's from either Chubdo's analysis, and he's also quoting other people who've analysed that, but the mathematics is there to read through. And I'm happy with it because Professor Fenton's looked at it. So hope you saw that video we did with Professor Fenton. He's one of the leading professors of risk in the country. This is what he does all day, every day. He's just retired, actually, but I think he's still officially a professor. He'll be an emeritus professor shortly, but he's done this work for years. He understands it, as you'll see from the video, which I struggle to understand, but a very interesting video nonetheless. Anyway, so basically, and we don't know, but it sounds like if the vaccinated were counted as being unvaccinated for 2 weeks, there'd be at least 602, and that means that the differences simply disappear in a puff of smoke. They would no longer be there. This misclassification can be used as a mathematical trick to make things appear what they are not. And again, talking about mathematical tricks, do watch that video with Norman. Now, seriously, death at the scene, these were excluded. So if people in accidents, paramedics turn up and tragically some people are dead at the scene. Now, if someone's dead at the scene, there's two reasons for that. Two possible reasons for that. One is they were killed by the trauma of the accident. Another is they had something that caused them to faint or have a cardiac arrest or have some immediate loss of consciousness, and it was that loss of consciousness, say the cardiac arrest, that caused the accident. And we know that myocarditis is a side effect of vaccines. We're allowed to say that, and we have to point out that it's very rare, but we are allowed to point out it's a side effect of vaccines. But these were excluded. Why would they exclude these people that were dead at the scene? Some of whom may have died, or some of whom's loss of consciousness may explain the accident itself. Why on earth would you not want to lap that data up and analyse it to get to the truth? But they didn't. They excluded that data. So that was excluded, and there was 42 deaths at the scene. The 8 deaths that were included had been already transported to hospital. Now, given that only 550 people were actually admitted to hospital, thankfully most were just discharged with more minor injuries, that means 84% of the death count were ignored. In my mind, this is no way to pretend to do research. This also excludes all sudden deaths that resulted in an accident. I don't want to be cynical and say conveniently, but some might say that. So they didn't have to face that issue. What an opportunity wasted to really get some of that data, to see if acute cardiac events are causing fatal road traffic accidents. What a missed opportunity. Anyway, let's go on. What about people not in the system? This is Dr. Claire Craig. Do check this out. She gives pretty good rationales on her Twitter page there. Pathologist, of course, data analysis. Remarkably clever person. Unvaccinated are typically underestimated. So the unvaccinated numbers are actually higher than you would think. And this, as Professor Fenton points out, would change the denominator. Therefore, all your sums go wrong. Therefore, the rate of incidence of anything overestimated in the unvaccinated. So the rate of incidence of anything will be overestimated in the vaccinated because you haven't got actually the right proportion. So you can be overestimating the number of people who were unvaccinated that were involved in road traffic accidents, or died, or developed complications, or like porridge for breakfast, or like a beer with a supper. You know, it could be anything. Because the denominator is wrong, because these groups aren't fully understood. because unvaccinated are typically underestimated. The rate of incidence of anything is overestimated in the unvaccinated. And this tends to happen by a consistent amount as well. So this is a bit complicated, but I'm going to show you anyway. So here we have the forest plot from the this is from the paper. We have this forest plot here. Now what we have here, this line going down here shows no increased risk or no decreased risk between the vaccinated and the unvaccinated. So we see that here the unvaccinated have an increased risk of everything, apart from the over 65s for reasons we've talked about already. So these are all people that are unvaccinated with greater risk. So alcoholism, yes. Alcoholism, no. Doesn't matter, you've still got a greater risk if you are unvaccinated. Sleep apnea, yes. Sleep apnea, no. Doesn't matter, you've still got a greater risk of having an accident if you're unvaccinated. But what Claire and Norman both pointed out is that the degree to which this risk is increased, despite these things are also disparate, so you've got alcoholism, you've got rural home, you've got men and women, you've got age groups, you've got depression, you've got high blood pressure, you've got cancer, all these different things, they all seem to increase the risk of the unvaccinated by about the same amount, because these all cluster around a line which is about here. They all cluster around a line about there, indicating that there's some consistent systematic bias which is pushing these things that way. So in actuality, the line should probably be about there, and that would only really leave dementia as an outlying risk. So because these are so well clustered, it indicates that it's not these individual things that are causing them to go over here into the greater risk, but it's actually some consistent misinterpretation, such as underestimating the amount of people that are unvaccinated, because the vaccinated percentage is probably way higher than 16. It could be 18, 20, 22, 24, something like that. So just that sheer clustering indicates that there is some systematic bias going on here from their own forest plot. And needless to say, the authors appear to be oblivious of this factor. Now, nearly done. So the rate of incidence of anything is underestimated in the vaccinated. So the rate of incidence of traffic accidents is going to be underestimated in the vaccinated because of the change in the denominator, because the actual number, because official figures typically underestimate the amount of unvaccinated. Therefore, the denominator's wrong. Therefore, these risks are all wrong in a consistently wrong direction. Seems to be what is happening here. So, for example, COVID cases, hospitalizations, deaths, car accidents are all going to appear to be higher in the unvaccinated than the vaccinated, because the actual number of unvaccinated is a higher percentage than we typically, our official figures, believe. So if you're unvaccinated, you're at greater risk of pretty well everything else if this form of analysis is used. And it's surprising the authors didn't discuss this. That surprises me. So as we say, the forest plot, in all subgroups, the risk of increase, the risk is increased by the same amount, indicating a possible systematic bias. If you want to analyse this yourself, you basically can't. The study data set is held securely in coded form at the Institute of Clinical Evaluation Sciences. And the authors kindly say they'll tell you how they got it. Read the paragraph. I didn't really understand it. It was a very complicated paragraph. But basically it means that this data is not in the public domain. So independent analysts, as we say, like Norman and Claire, don't have access to it, which I find unacceptable. That selected groups can use data to come to particular conclusions, but others can't. So that's my summation really of, as I say, not really my own work. Most of that comes from people who are much better at analysing these things than me. Because I actually read this and thought, just a minute, this actually sounds reasonable. I knew it wasn't, because it's just too absurd. But it kind of sounds reasonable. And it really is quite, you need to be quite a good data analyst to work out why this study is potentially bunk. Thank you for watching.